Hi, and welcome to our lesson on transformations with congruence and similarity. Transformations are those things that are changing our figures on a graph, such as translations, some kind of slide on our figure, or reflections, some kind of flip. Rotations are going to be some kind of turn, or dilations, some kind of shrinking or stretching. Some of these changes cause our figures to be congruent when we look at the first image and the second, and some of them cause them to just simply be similar, which means same shape but different size. So we're going to take a look at which ones cause congruence and which ones cause similarity, and look at the visuals on the graph of those. You need to know that when we're performing one of these transformations, we usually call the first image our pre-image and then the final image our image. So remember, congruent figures are going to mean that they have exactly the same shape and size. They look exactly the same. Whereas similar are going to be the same shape but different size. Congruent figures can be obtained by performing translations. When you're sliding your shape, you're not going to change the size, you're just going to change the location. Rotations are just going to, again, flip them. They won't change the size. Reflections will flip. Rotations actually turn our pre-image, and our new image will just be turned to a different location on the coordinate instead of a change in size. Alright, so here's an example on the graph of some congruent figures. Exactly the same shape in different locations. This would be a slide of a certain amount of units diagonally, so this is what we call a translation. A translation has been performed and we still have congruent figures. If we take a close look at all the side lengths on those triangles, we're going to see that each corresponding side has the same distance, the same amount of units as the other triangle, so that's why they're congruent. It's exactly the same lengths. Here's another example of some congruent figures. Notice that at first glance they don't look exactly the same, but we can see that each side has a matching side length in this second image here. There's our 3, and then the two sides are both 5 inches. So what's happened is this figure has just been turned, possibly rotated or reflected in some combination, but it's still the same figure, so these two figures are congruent. Alright, let's move to similar figures. Notice that I've got two rectangles on our grid here, and they look basically the same shape, but they're definitely not the same size. So let's see if they are similar figures. To be similar, they're going to be the same exact shape, meaning the sides will be proportional. Okay, so we're going to take a look here. Let's take this top side, for instance. I can see that this smaller rectangle covers 2 units, and in the larger rectangle, it actually counts over 6 units. So the top side has a relationship of 2 to 6, or we can say 1 to 3 if we reduce that. So if all of these corresponding sides have that same relationship, then these figures are similar. So take a look at the right hand side here. This spans across 3 units, so that means with a 1 to 3 relationship, this right hand side on the bigger figure should span across 9, and if we count that, we will actually find that that is true. Filling all these in, they will follow the same relationship. What's happened here is there has been a dilation performed on this pre-image to create the final image. Dilations, remember, are shrinks or stretches to our figures. Okay, remember our shapes had the same shape, but they were not the same size, but they did have corresponding sides that were proportional. Let's go name those proportional sides, because sometimes we'll be asked to do that in a ratio form. So what we'll do is we will take our figures, and if they don't already have labels, we will put some letters at the vertices. So let's call our small rectangle ABCD and our large one EFGH. So remember our corresponding sides here. We had the top related to the top of our second rectangle, so that's AB was proportional to EF. So let's list that in. Side AB proportional to EF. All right. And then another matching pair of sides is BD to FH. You can see that from small to large. BD, FH. So we'll write that in. BD is to FH with the same relationship. Okay. And then bottoms, we've got CD to GH. And then last one is our left-hand side. AC is to EG with the same relationship. So there's our list of proportional sides if we need to do that in our problems. And this concludes our lesson on transformations with congruence and similarity.